giving the formulas in this lesson, so we'll talk later more about like where they're derived from and where they come from. So we're going to look at double angle formulas and half angle formulas. So here are your double angle formulas, and again, you can get these from the book. So cosine of double some angle equals the cosine squared of the angle minus the sine squared of the angle. Or, because we could substitute for cosine squared or for sine squared from our Pythagorean identity, we could get these other versions of the formula. Then for sine of double an angle, that's equal to 2 times sine of the angle times cosine of the angle. So what this means right here, double the angle, means like if you were trying to take the sine of 60, which we know that, I understand, but in a different circumstance, and you didn't know the sine of 60, but you remembered stuff about 30, you could do 2 times the sine of 30 cosine of 30. Okay, so that double angle just means you're trying to find something, sine, cosine, or tangent, about something that is double another angle, and you would rather use the other angle instead. So the tangent of 2 theta equals 2 times the tangent of theta over 1 minus tangent squared theta. Okay. And then half angle identities are similar, but they're just written in ways that they are half of the angle. So like, for example, the cosine of half of an angle. For example, if you wanted to find the cosine of 15 degrees, I don't know anything about 15 degrees, but I could think of 15 as being 30 divided by 2, and then with a 30 right there for the theta, if I could just use the 30, I would be able to figure stuff out about this angle. So this is plus or minus. Now, it's not both. It's one or the other, and it depends on where you end up on the unit circle. So we're going to have to think about that information. Okay? So the sine of an angle has half an angle. So for example, the sine of 15, we would actually go through and we think of 15 as 30 divided by 2. And again, plus or minus, meaning not both in this case, but one or the other depending on what you know about the angle. And you would do 1 minus the cosine of 30, all divided by 2. And then for the tangent of a half angle, we would get plus or minus, and we'd get 1 minus cosine of theta over 1 plus cosine of theta. Okay? All right, so we're going to use these like we were before. We're going to use them to calculate things, and we're going to use them to prove things. So for example, how would we prove tangent 2 theta equals 2 tan theta over 1 minus tan squared theta? So what I'm going to do is I'm going to think about rewriting the tangent of 2 theta. So here's just one example. If you can come up with a different way, that's awesome too. All right, so I could think about it as theta plus theta because that's 2 theta. And then that means I can use my sum formula that we talked about yesterday. So the sum formula says when I have 2 angles inside of a tangent that are being summed, I do tangent of the first angle, these are like my alpha and beta right now, and tangent of the second angle divided by 1 minus tangent of the first angle times tangent of the second angle. Now, those are alpha and beta, or 2 different angles in this case that just happened to be the same. So now, because in the numerator I have like terms, this is 2 tangent of thetas over 1 minus, and here, because they are the same factor multiplying each other, I'm getting tangent squared theta, okay? Which is what I was looking for on the other side. So that's one way that I could verify this. If you have another way, definitely bring it to class on Monday. All right, what's the exact value of the sine of 270 using a double angle identity? So basically what this means is, let's say I wanted to find the sine of 270, okay? But I didn't know anything about 270. It's not true, we do. So I'll do a different example of this in a minute. But I could think of 270 as being 2 times 135. That is the same thing as 270. So this right here is being compared to this. So we're going to use our theta is going to be our 135, and we're going to go back to the formula that we used before. So for sine, it's just 2 times the sine of theta times the cosine of theta. So this is 2 times root 2 over 2 and negative root 2 over 2, which gives us, these would make 2, and 2 times 2 would make 4. Here, 2 times 2 would make 4. Negative 4 over 4, negative 1, which we know to be true because we actually know the sine of 270. But again, so the purpose of this is to rewrite the angle as 2 times an angle, and then this is now the angle that you use in the formula. Here it might not seem that useful, but again, it would be useful if you were trying to find something that you didn't know the angle itself until you wrote it as a double angle identity. All right, so the next thing we're going to do is verify an identity. So remember, our goal is to plug stuff in until we can find different manipulations of it. So we'll go ahead and start on the right side. And again, that's your choice, but I'm going to go ahead and try this. So if I do this, let's see. One way I could do this is I could factor out the 2 and the tangent if I want. And if I did that, that would leave me 1 minus sine squared. 1 minus sine squared is the same thing as cosine squared. Now what's going on in my head is that, like, I might see, I don't know how that's the sine of 2 theta. But what I'm thinking in the back of my head is what I know about the sine of 2 theta is that it's equal to 2 sine theta cosine theta. So I'm really trying to get this, and then I can convert it to that as my last step. So you can see I'm close here. I have the 2, but I don't want anything with tangent. So I'm going to rewrite tangent as sine over cosine. And so this cosine will cancel out 1 power of those cosines, leaving me with 2 times sine theta times cosine theta. And that's what I was looking for to be able to call it sine of 2 theta. So again, in this case, that identity is just acting as a way for us to manipulate or rewrite things. So it's either going to be used for a calculation or to rewrite things. Again, if you have a different way of doing that problem, make sure you bring it to class. All right, what is the exact value of 195 use half angle identities? Okay, so the tangent of 195, let's say I don't know anything about 195 and I want to use a half angle. That means what I want to do is rewrite 195 so it's worth the same thing, but it looks like half of something. So 195 would equal what over 2? So in other words, what's double 195? 390. So then if I use the formula, and remember you're going to be given the double and half angle formulas on the test, okay? Then the formula says that in order to do this calculation, I need to choose plus or minus, and I need to do the square root of 1 minus the cosine of 390 over 1 plus the cosine of 390. All right, and remember that the plus minus part here is not about both plus and minus. It's about what you're trying to find the tangent of. So something else has to be going on in your head, like where is 195? Which quadrant? So I know 195 would be somewhere in this third quadrant. The tangents in that third quadrant, because it's a negative x coordinate and a negative y coordinate, have positive tangents. So I'm going to choose the positive in this case, not arbitrarily, not randomly, but because I know where the angle is. So for 390 is like the same thing as a 30-degree angle. So this is going to be positive. 1 minus the cosine of 30 degrees is root 3 over 2. 1 plus root 3 over 2. If I make common denominators in both, so if I write these ones as 2 over 2, I have the square root of 2 minus rad 3 over 2 being divided by 2 plus rad 3 over 2. Okay. Sorry, I'm going to have to continue over here. So 2 minus rad 3 over 2 divided by means multiplied by the reciprocal of 2 over 2 plus rad 3. And that's still all underneath a radical. So I'm getting 2 minus rad 3 over 2 plus rad 3. Depending on how much they want us to simplify it. So I'm going to go ahead and rationalize this by multiplying top and bottom by 2 minus rad 3 within the radical. So in the numerator, that's going to give me 2 minus rad 3 being squared. And then in the denominator, if you multiply this out, you get 4. The middle terms will cancel, minus 3, which is just 1. So the square root of a perfect square is just going to give us 2 minus rad 3. Okay. All right, so 195 is something that normally we wouldn't have known about, but we could know about it because of these half-angle identities, so this is where the calculation would come in handy. All right, so the last thing we're going to do is this problem. So given that the sine of theta is negative 5 over 13, and theta is between 270 and 360. So I know that the angle's in here, okay? I know that the sine of the angle is negative 5 over 13. So wherever that angle is, the y-coordinate can be thought of as kind of some multiple of negative 5 and the radius a multiple of 13, which means this would be 12 and it would be positive. They ask us what's the tangent of theta over 2, and remember, this is our formula that we were using. In the numerator, it's 1 minus cosine over the angle, and in the denominator, 1 plus. So for us, the cosine here is adjacent over hypotenuse, so 12 over 13. So this is plus or minus 1 minus 12 over 13 over 1 plus 12 over 13. And again, we're going to make common denominators and simplify like we did previously. So the square root of 1 over 25 is 1/5. And then how do I choose the plus or minus? So look at where we're at on the circle. If theta is between 270 and 360, then theta over 2, if we divided everything in half, would be between 135 and 180. So the half angle is somewhere over here, which means it's in quadrant 2. And so it would have a negative and a positive coordinate, so the tangent would be negative. So over here, I'm going to choose the negative value. Oops, and the square root shouldn't be here anymore, I'm sorry, because I took the square root of 1 over 20. So this should just be negative 1/5. All right, just take the notes. If you think you can do the homework, go ahead and do it, but you don't need to do it until Monday night.